Here's an example of where we would use Coulombs law in order to figure out the force that you have between two different charges. In this example, we're just looking at two specific charges. So the charge on the left is positive 3 times 10 to the negative 6 coulombs. The charge to the right is negative 4 times 10 to the negative 6 coulombs. So here's how you'd use Coulombs law. We know that F equals K Q1 Q2 over r squared, where K again is that constant 9 times 10 to the ninth newtons meters squared per coulomb squared. Q1 and Q2 are the different charges, and then r is the distance between them. So the one other thing I need to give you is the distance between them. So let's just say that this is 0.13 meters that's in between them. So 13 centimeters we have separating these two. Now, here's what we need to do. If we need to figure out the force between them, all we do is we take the values of our charges along with our constant and our distance, and we just plug them into the Coulombs law equation. So F equals K, which is 9 times 10 to the ninth newtons meters squared per coulomb squared, times Q1. Now for Q1, it doesn't matter which one's Q1 and which one's Q2. Key thing is just keep those positive. Don't worry about the negatives that we have in there. So 3 times 10 to the negative 6 coulombs. I'm just going to use the one on the left. The one on the right is 4 times 10 to the negative 6 coulombs. Again, not worried about that negative that's in there. Divided by the distance between them squared, divided by 0.13 meters squared. So when I figure this out, all I really have to do is just evaluate that. So let me grab my handy dandy calculator, and let's figure out exactly what this is going to be. So we have 9 times 10 to the ninth times 3 times 10 to the negative 6 times 4 times 10 to the negative 6, and that's divided by 0.13 squared. And that's going to give us 6.39 newtons. So if you try that, you should get 6.39 newtons. Now the other thing you have to determine is, what does that mean in terms of the direction of the force? Since force is a vector, you have to figure out the direction of the force. So we have this force of 6.39 newtons on the one on the left. Now according to Newton's third law, we have the equal and opposite force of 6.39 newtons on the charge on the right. So what we have here, if I just kind of label above each force, or sorry, above each charge, we have 6.39 newtons of force acting on that one. We have 6.39 newtons of force acting on that one. We just have to determine the direction. And the direction is just determined by the nature of the charge. Since the one on the left is positive, the one on the right is negative, we know that the force is going to be attractive. These two are going to be attracted to each other because they're opposite charges. So this one, the force is going to be to the right. So that this one, the force is going to be to the left. And those are the two forces that we have in each one. And we're done.